Hi everyone, Mrs. Summer here to talk about balancing equations day 3, or probably more exact, lesson 3 on balancing equations, lesson 307. The objective for today is that students will be able to model the law of conservation of mass by balancing chemical equations using coefficients. So if you recall, chemical reactions occur when bonds between atoms are broken and new bonds form. They involve the making of new materials with new properties and also involve energy changes. They are written as chemical equations. The coefficients tell you the number of each molecule. Subscripts tell you the number of each atom. Conservation of matter, or conservation of mass, is that matter and mass cannot be created or destroyed during a reaction. It can only be rearranged. And because of this conservation of mass and matter, a chemical equation must be balanced. You also recall that when balancing a chemical equation, you can add or change coefficients, but you cannot add or change the subscripts, because changing the subscripts changes the compound. And recall, step 1 to balancing the equations is you write the correct formula for the reactants and the products, but don't try to balance it yet. You must write the correct formulas first. And once you write them, do not change the formulas. So in this example, we have aluminum bromide and potassium sulfate react to form potassium bromide and aluminum sulfate. So I have aluminum, so Al bromide, Br3, plus potassium sulfate, so K2SO4, react to form potassium bromide and aluminum sulfate, Al2SO4, 3. Step 2 was to draw a table under the reactants and products. Find the number of atoms for each element on the left side, the reactants, and find the number of atoms for each side on the right. And once again, my yield sign did not come through. And so on this side, aluminum, I have 1 aluminum. For bromine, I have 3 bromines. Potassiums, I have 2. Sulfurs, I have 1. Oxygens, I have 4. On my product side, aluminums, I have 2. Bromines, I have 1. Potassiums, I have 1. Sulfurs, I have 3. And oxygens, I have 12. Step 3 is to start placing coefficients in front of formulas, and then retotal the number of each atom every time you place a coefficient. So I'm just going to start. Remember, balance hydrogens and oxygens last. So you can start wherever as long as you're leaving your oxygens and hydrogens to last. So I'm going to start by trying to balance the aluminums first. So by doing that, I need to put a 2 here. And by placing that 2 in front of aluminum bromide, I now have 2 aluminums and 6 bromines on my reactant side. And now I'm going to do try to balance my bromines. So I have 6 bromines on my reactants, but only 1 on my product. I'm going to put a 6 in front of my potassium bromide. By doing that, I now have 6 bromines on the product side, but I also have 6 potassiums. Next, I'm going to try to balance my potassiums. So I have 6 on the product, but only 2 on the reactants. So I'm going to do that by placing a 3 in front of my potassium sulfate. And when I did that, my number of potassiums changed to 6. My number of sulfurs changed to 3. My number of oxygens changed to 12. And if we look across, aluminums, we have 2. Bromines, we have 6 on both sides. Potassiums, we have 6 on both sides. Sulfurs, we have 3 on both sides. And oxygens, we have 12 on both sides. So yes, it is. And we're in the lowest whole number ratio with our coefficients. And step 4 was to check your answers to see if the numbers on both sides of the equation are balanced, and they are. And if the coefficients are in the lowest possible whole number ratios, which they are. Here's an example that I want you to try. Sodium phosphate plus iron 3 oxide reacts to form sodium oxide and iron 3 phosphate. So as we go over this, your formulas are Na3PO4 plus Fe2O3 yields Na2O plus FePO4. So this is before it's balanced. So on our reactant side, we have 3 sodiums. We have 1 phosphorus. We have O4 plus O3. We actually have 7 total oxygens. And then Fe2, we have 2 irons. On the product side, we have 2 sodiums. We have 1 phosphorus. We have 1 oxygen plus 4 oxygen. We have 5 total oxygens. And we have 1 iron. Remember, we're going to save our oxygens balancing till last. And I'm going to start by balancing my irons. So by balancing my irons, and I'm balancing my irons because I know that it's super easy, 2 and 1, to just put a 2 here. And now my number of irons have changed. Number of phosphorus has changed. And my number of oxygens, I have 2 times 4 is 8 plus 1 is 9. And I have 9 oxygens. The next thing I'm going to try to balance are my sodiums. The sodium one is a little tricky because I have 3 on one side and 2 on another, which means I have to do something to both sides in order to make those balanced. And that something is by putting a 3 here. So now my number of sodiums has changed, and I've got 6 sodiums. And my number of oxygens, 3 times 1 is 3, plus 8 is 11. And then over here, I need to put a 2. So I now have 6 sodiums. I now have 2 phosphoruses. And now 2 times 4 is 8. Plus another 3 is 11. Now, by doing those things, everything is balanced. I have 6 and 6, 2 and 2, 11 and 11, 2 and 2, and my thing is balanced. My equation is balanced. And here's the other example of this, much nicer than my own writing.